How many basic variables will there? 3 constants, 3 basic variables. So we want to know what is the sum of the basic variables. Is it all right? Then sum of the basic variables just before the last iteration. Okay, that is the second part. In the last iteration, we find the inverse of a basis matrix. Okay, inverse of a basis matrix, where some of the elements of the first column is, see, we find the inverse. We are talking about the inverse of the basis matrix. In the last iteration, we find the inverse of a basis matrix. B inverse. So for the B inverse, not for B inverse, sum of the elements of the first column. In the last iteration, we find the inverse of the basis matrix where the product of the elements of the second column. See, something like that. And the last question is the inverse matrix where the sum of the elements of the third column. It's very simple. If you find the B and B inverse, everything is done. First, second, third. So you try this problem. Not now, you can try later on. Is it a difficult problem? Of course, it's lengthier because all the 3 steps you have to follow to solve it.
So can
only 30 minutes.
Can?
Sir, say only 30 minutes are there. Means 5 parts are there.
You are doing everything in group, no?
No, sir.
Whatever the answer I find for one student, same answer for other students. So you divide.
So it's not fair to assume that everyone in that.
30 mark, okay, all right. If out of 30, if 10 is getting, I will put the 10 is the highest mark. Okay, that is all right. If so highest mark is 10, the 10 is, I will convert the 10 to 30. It is okay. Whatever you are doing, it should be correct. So in the 30 minutes, at least one problem you will be able to solve, no? Out of 3. But I should not mention that you should answer only one. Okay. So answer, see the highest, we'll see if it is relative grading, something like that. So we'll see. But now, what I have seen some people have done, you got the full answer. How they have got? What is the basis? Tell me.
Sir, not possible. If we do by hand, it is not possible to do in 30 minutes.
See, it is not possible, I'm telling, but still people are doing. How are you doing? Okay. And this question you got, and anything wrong you are observing? If somebody was saying that infinity is coming somewhere. This, you
sir,
know,
yes. First question, sir.
Which question?
First question. This
tell me.
Sir, if in basic feasible solution, if we take x2 and x4 as 0, then both the constraints became identical. So I got infinite.
See, the question is like that. So for a positive integer k, this LPP has dash number of, for positive integer k, if k equal to 0, okay, so k is 0 means it is, you know, the 0 solutions we are observing. Okay, so for a positive integer k, this LPP has, you can see this is 5k, this is 5k. Okay, so has dash number of basic feasible solution. What is your answer?
Sir, I got infinite in this answer. Infinity number.
Infinite how?
Sir, we have 4 variables and
which one you are, right? Which one you are just saying 0?
X2 and X4.
X2 and X4 0. So
both equations become identical.
See, I'm telling you. X1 plus 2x3 equal to 5k. Okay.
Yeah.
So X1 plus 2x3 equal to 5k. Okay. Right? There are 2 equations. Is it invertible?
Both are identical, sir. So
it is invertible.
No, sir.
Sir, both are identical, sir.
See, you could not understand the what I have taught in the very beginning. How to find the basic feasible solution. See, basic feasible solution, what you do? So, out of m plus n, because generally m equation, n unknowns. Okay, so and after adding all these things you are saying now, here it is how many out of this is 4. Out of 4 you have to set 2 of them, they are 0. Okay, so 4C2. So how many are there? 4C2, 4 into 3 into 2, so 6 are there, isn't it?
Sir,
4C2 now?
sir,
6.
Let us take x2 and x4 as 0.
अरे
sir.
बाबा सुनो, मेरा बात you just listen. Okay, so 2 are 0, so 4C2 there are 6. We will explore all the 6. Okay, all the 6. Okay, so whenever you see after actually the system is a into x equal to b. Okay, a into x equal to b. So if some of the variables you are setting 0, then it will be b into x equal to b, capital B, that is basis matrix into x equal to b. And you have a solution if the determinant of b is non-zero. Please remember, here it is becoming 0. So in this case, it is not possible. It's gone. Okay. So that I have told. B, the determinant, it is invertible if we are finding this determinant is non-zero. So what you are saying, in that case, you will not have any solution. That is gone. Okay. So out of 6, you have to explore in this manner. And you are not reading. So let me say where it is there. So you have got the slide now. The basic feasible solution, how to find the basic feasible solution? Okay, I am showing the slides. Okay, just here, 1 minute. Basic feasible solution. Here you see, we may select m variables out of n variables setting at this many variable 0. The system ax equal to b becomes b into xb equal to b, where determinant b is not equal to 0. If it has a solution, then it has this determinant b is non-zero. It is 0. So if it is 0, then how can you find inverse? Okay. So this possibility here itself you have not observed. It has solution like xb equal to b inverse b. If this is b is non-zero, then if b is 0, right? This point you have not noted properly. Okay. So out of 6, all 6 cases may not come. If it is coming, it is fine. Some problem it may not come. Okay. Anything else you want to say?
Okay, sir, understood.
This point you see. But again, you say that, see, for example, you are right. There are 2 equal equations are equal. You will take one of them. One of them you will take. And if you are taking one of them, what you are finding in that problem? What you are finding? I'm coming to that. What you are finding? So you are finding x1 plus 2x3 equal to 5k. According to you, x1 plus 2x2 equal to 5k. How many solution it has? Again, what you will do? Tell me. Again, you will do. So there are two variable, one equation. You will set one of them 0. Okay, x1 0, then you will find x3. So that way your work will increase like anything. Okay, don't bother about that. Okay, so here it may happen sometimes, you know, x1, 2 are the variables. If one of the variables becoming 0, other is positive, we are getting a basic feasible solution that is degenerate. And sometimes non-degenerate. That question is not there. We are asking how many are there? How many basic feasible solution? The easiest question is that. So you have not understood, because one day you are attending class, next day you are not attending. How will find this thing? Okay. Okay. Anybody has answered? How many are there? How many basic feasible solutions are there? How many?
5.
Yes.
5. Because one of them is infeasible. The rest of them you can solve.
5 basic feasible solutions are there. But people are getting full mark. How? Anybody? Not 5. It is other than 5. You just check. Now you check. See, in this manner you will do. Say keep something like say x1, 4 are there, no? x1, x2, 0, x1, x3, 0 are 0, then x1, x4, 0, then x2, x3, 0, then x2, x4, 0, then x3, x4, 0. They are in this manner. Okay. 6 cases. Try. Now you try. Put k anything. Okay, no problem. Any positive integer. Any positive number, let us say. K equal to, let us say k equal to 1 and try. Where is the problem? Okay, equal to 2, you can try. After that, it has at best dashed extreme points. Every basic feasible solution is an extreme point. Okay, every basic feasible solution is an extreme point at best. Maximum number extreme points. How many are there? See, the first problem you cannot solve, then you have not learned the linear programming. All my labor, all my shouting gone. Where? See, this actually deliberately I have skipped. I will tell you, again I am repeating. That is a theorem. Okay, see theorem. What is the theorem? These slides, you got it? Yes or no?
Yes, sir.
Basic feasible solution. The basic feasible solution will satisfy the condition this. Okay. Non-degenerate solution. It is a basic feasible solution which is exactly m positive out of n. Okay. Forget about that. I am coming to the some theorem. Which theorem it is? Every basic feasible solution is an extreme points of the convex set of the feasible region. Every basic feasible solution. Okay. So the number of basic feasible solution is number of extreme points. Okay. And solution occur, optimal solution occurs at the extreme point only. This theorem 4, it is very simple, but something you have to understand thoroughly. Theorem 4 you have understood? Anybody has not understood, I will explain again. Every basic feasible solution is an extreme point. How do you prove? The proof is given here. And if you cannot realize, then you tell me, I will again explain. Actually, that question is taken from this theorem. See, I have in a mail I have written here, if any query or anything you want to, because you know you are in the classroom. I don't know when the classroom will start, maybe from the 10th March or this that. So we can repeat some of the things, no problem. Okay, so at least what I am writing you will try to understand, but here I am unable to write. Okay, it is possible, but you know such facility is not there with me, and I thought it will be easier and everybody will know, because I am writing, somebody will, you know, you will not copy this that. So here I am explaining what exactly has to be done. This slide you got? Just casually read, and if there is a doubt you ask me, I will explain. Okay, don't worry for the mark. Okay, so you will get very good mark, and it is a very good subject. And many things are there to learn in a very short period. Simplex method, big M method, two-phase simplex method, revised simplex method, dual simplex method, dual primal combined simplex method. So these are the methods, and these are only, you know, for a particular problem, particular method will be applicable. And among this method, the, you know, if you are writing codes, the revised simplex method is easier for you. Revised simplex method. Okay. Have you written? First, you write a code to find the product form of a inverse of a matrix. And there itself, I have explained, if you are changing first column, what you will do. If you are changing the second column, what you will do. If you are changing third column, what you will do. Everything. And if you cannot realize, then there is problem. Okay, the pivoting element cannot be 0. Please remember, either in primal simplex it is positive, in the dual simplex it is negative. It cannot be 0. Okay, any doubt anywhere? See, these 3 questions, okay, and I have asked you solve yourself and send again to me. I want to know whether you are able to solve or not. Okay, of course, the time is a problem. So now, when you are sending me, so don't worry for the time. You just simply write your answer in the piece of paper. Let us say, so there are 3 questions, 3 pages you write and send to me. Okay, and don't take the help of anybody. So that I know that yes, you have done. Okay, see this question when the exam was taken when 15 days back. Yes or no? Today is in 1st March, no? Okay.
Yes.
50. So around 15 days, it's 2 weeks gone. So 2 weeks gone. So if still you cannot solve the problem, but the question was not known. See, you could have taken the screenshot or something like that. Okay. See, when you get the question, you take the screen. You have the mobile, no? Who is denying? What you are doing, that is up to you. Whether you are solving or your friends are solving, who is solving, we don't bother. Now you have to reproduce the answer. Now, if you are giving some answer, I will ask you some question. How you have got? You have to explain. Get ready for that. Now you say that after setting this 0, I'm getting the same equations. So according to the theorem, it cannot be a method to find the basic feasible solution. And why simplex is coming to the picture? Because if the number of variables are more, okay, let us say number of variables are 100 and number of equations are 50. Say 100C 50. A huge amount of basic feasible solution possible. This many extreme points. So optimal solution occurs only at the extreme point only. How do you search? It will be quite lengthier. So we need some shortcut method. So the simplex say that you see it is moving one point to other point. So these 2 points are what is that? Adjacent, neighboring points. One point to other point. A, then B, then C, then like that. It will not cover all the points. After few iterations, you will find the optimal solution. There is no improvement. Simplex say the interior points method say what I have told you earlier. I have sent some paper. So it is from the center, it is moving to extreme points. From center to extreme points. Center. Feasible region. Let me say we have a feasible region that is closed, bounded. Okay. So consider the center. Okay. For example, you take a triangle that is the feasible region, and center is the so okay, say so start up initial point at the center. Then so the solution, the optimal solution will move from center to one extreme point, one of the extreme points. It may be also both the 3 extreme points. So 3 points may not be solution, maybe 1, maybe 2. That depends on the problem. Anything else you want to say? See, the question number 1E. 1E. So this is an optimal solution of the LPP for a unknown value of K. Then K equal to how much? Now you substitute here. So 6, 1, 3, 1. 6 plus 1, 7. 7 plus how much here? 7 plus 6. 13. 13 plus 2, 15. So the left hand side is 15. 5K. What is the value of K? K equal to 3. Now you see the second equation. 6 plus 2, 8 plus 8 plus 6, 14 plus 1, 15. 15K. So K equal to 3 is over. But please remember this. I'm saying this is an optimal solution. How? So actually, 2 of them, this problem has several optimal solutions. Okay, say 2 of the points are 0, 2 are non-zero. Okay, so we have taken some convex combination. As a result, this is known. Okay, so lambda times x1 plus 1 minus lambda times x2. Okay, and you have observed already. So if that is the solution, so and we have got k equal to 3. Is it okay? How much time will it take? 2 minutes? Anything else you want to say? Who are the students are available? Just tell me, I will note down. They should not lose mark. Okay, you're attending. Okay, tell me your roll number.
Sir, 20 CS 10060.
20 CS computer science. Okay, and your name is?
Sir,
Soni Aditya Bharat Bhai.
Achha. 20 CS. So many students are CS. 20 CS
10060.
100
60.
6
0 60.
60 is there. Ah, yes. Soni Aditya. What is that?
Soni Aditya Bharat.
Achha. Okay, good.
So 19 MA
Yes.
20065.
Loudly.
19 MA 20065.
Okay. 19 MA 20065. Mathematics student, no?
Yes, sir.
Your name, please.
Maitri Swaroop.
Oh, Maitri. You are from which place, Maitri?
So I'm from Gurgaon.
Gurgaon. You see, I have remembered one professor has wrote a book on operation research, Kanti Swarov. So you know him?
No, sir.
He is from Delhi side. Okay, Maitri. You repeat your roll number again.
So 19 MA 20065.
65.
Yes, sir.
Okay, this present.
18 HS.
Then
18
sir,
HS.
20 CS.
18.
18 HS. 200 44.
Your name?
Vitthal Agrawal.
Agarwal. Bithal. Okay. And anybody else?
20 CS 10082.
So,
20.
CS 10082.
10082.
Sir, 18 CS.
Your name, please?
Siddharth Vishwakarma.
Vishwakarma. See, because people are not able to join, some student, I know him, he was saying, say, hall president is giving some work, so I have to do it. Otherwise, there will be some action. What is the work they are giving in the evening? But I don't know why I could not connect, because maybe some people must blocked my MS Team. Is it possible?
No, sir, that isn't
Not possible.
It must be a technical issue from the
Technical issue. But how it was solved? Because I don't know. Just after 1 hour I tried, then it is coming. Okay, all right. This is not an issue. So
20 CS.
see, I am happy to answer all your questions if you can frame and you can ask. Okay. So if you ask question, then you will learn. And if you learn, then you will achieve. And if you will achieve, you will go off. So that is, remember, you should ask question. So sometimes in the classroom, you can ask, sir, this is the doubt here. See, if you would like, I can send the slides in advance. But if I am sending the slide in advance, you will not count the class. That is the problem.
Sir, 18 HS 20004.
18 HS
20004.
20004.
Sir, 18 CH 300.
Wait.
18 HS.
I have to look at your 18 HS
200.
Adhiraj.
Yes, sir.
Adhiraj Rastogi. Okay, then anybody?
20.
So 18 HS 20038.
18 SS, then
20038.
38. Okay.
Sir,
Sir, can
18
we write
20
R0
CS.
you are 2001?
Similar.
Yes. So
Okay.
18
Yes,
sir,
yes, sir.
20 CS.
Sir, 18 AE 30029.
Yes.
20
18
20 CS
AE
185.
300
29.
29.
Sir,
ठीक है.
18
20
HS.
Sir,
CS
17 divided
185.
2001.
Okay. So
20
now how many students are there? I can take the class.
Sir, 18 HS.
Sir, 20
Sir,
CS.
20 CS.
See, don't worry for the attendance. I will give attendance to everybody. No problem. Okay. So are you writing coding? And the coding you send to the mail ID what I told. If you send here and there, so it will be misplaced. You will not get any credit. I told wherever I have given, there you send. Okay, I will count. So and I will check. And when I check, I may call you and you presents. Okay, right? So and once you have done something, you will get the credit. Okay, what you exactly have done, you will explain me. Yes, this I have done. And what is so? If somebody similar programs are there. So what is the difference between this program and that program? I will ask also. You have copied or you have done something else? Okay, all right. So how many students are there? Please check. 20. How many are there?
22 students, sir.
25. Okay. So without this 7 o'clock, at least half an hour will touch, have the class. Okay, right? Okay. So we may repeat, no problem. But we'll have the class, no problem. Since you have joined. So.
Sir,
This question I'm telling everybody. Again you try and try to solve all the parts. And if any doubt, you can ask me. Sir, why the answer is like this? Okay.
Excuse me, sir.
So it is the easiest question. So only I have given just to you have to work. Okay. Yeah, you should.
Am I audible? 18 HS 20021 Lakshita.
Sir, you are muted.
Sir, you are on mute.
So you're not audible.
Now it is audible?
Yes, sir.
Okay.
Yes, sir.
Excuse me, sir.
Yes.
Sir, I am 20 CS 185.
You are telling your attendance?
Yes, sir. Yes, sir.
Your name?
Pranav Mehrotra.
Okay. Okay, I'll don't worry for the attendance. So at the end, you can call me and I'll call you and just I can note down. Okay. So see, I'm repeating again. So how you have established a cutting plane, a additional constant that I'm saying. This is the optimal simplex table. With respect to the optimal simplex table, so we say that the solution is non-integer. Then non-integer means cutting planes are required. If it is integer, then stop. There is no cutting plane. So we find here the basic variables value beta 1, beta 2 up to beta m. Some of the beta, maybe all, or at least some of them are non-integer. So if you find at least some of them are non-integer, then select the beta or beta I, which is largest fractional part. So with respect to largest fractional part, you have to start the, you have to form the cutting plane. But here there is a very basic point we have, you have to remember. So when you start the integer programming method, please remember all these parameters, all the parameters Cj, Aij, Bi has to be integer. If you find, for example, bi is given 7.5. Multiply by 2. Make it whole number. If you keep that half, there will be some problem, or that problem you cannot resolve at the end. So all the parameters, all the parameters are supposed to be integer. All the parameters. This is written once. Again, I will not repeat. But sometimes, if you forget about this one and you directly, without converting to integer, if you are trying, at the end, you will say that, sir, I am not getting solution, some problem. The problem is here. So every constant, every parameter has to be integers. Okay, right? So, for example, I am telling x1 plus x2 equal to or less than equal to 7 by 2, multiply by 2. Okay, over. So anywhere, more 7 by 3, multiply by 3. Okay, so in this manner, make all these parameters as integers. All these parameters, the cost coefficient, Aij, the technological coefficients, Bi, everything are integer. Okay, that's all. So this I'm repeating because generally the student commit mistake here. Okay. Now we are considering, assuming xi is a non-integer and it has the largest fractional part. So we have selected beta I. So with respect to beta I, xi plus summation over j varies from 1 to n, alpha ij double j equal to beta I. This, whatever I am discussing, it is there in the book H.A. Taha. Okay, Taha book you have. I think this, some sites it is free books are available, or you can have purchase a small book. It is available in tech market. Okay, so but any book, whatever you are purchasing, so don't sell it. Keep it the book. After some year, it will be again useful because you will not be able to locate that book again. Don't throw it. Okay, if you are thinking that yes, your career is on higher study, etc., or maybe a good engineer or a software, so you should keep that book. Okay, don't throw it. Okay, if you throw, you will suffer because this you cannot get. Okay, this I have taken from a textbook only. Okay, this. So, and as I told you earlier, this table, this simplex table, is the condensed form of the simplex table, not the extended one. Condensed. Yes or no? Because basic variables, non-basic variables together, the total number of variables. The basic variables I am naming as x1, x2, xm, and non-basic variables are w1, w2, wn. Okay. You see here basic variable in the column, and the in the row I say x1, x2, the basic variables, non-basic variable in the column w1, w2, etc. Okay. This. So once you have got, and we have to use the greatest integer function. Beta I equal to integral part of beta I plus fi. Fi lies in the interval 0 and 1. Okay, both sides are open. Similarly, alpha ij equal to integral part of alpha ij plus fij, and this fij is less than or equal to 1 and greater than or equal to 0. One side open, one side closed. Okay, this. But here both sides are open. Here one side open, one side closed. Okay. This I have already mentioned. How to find the greatest integer function? Say 2.5 is integral part equal to 2. Okay. Minus 3.5, it is integral part equal to minus 4. Okay. This you know. So I did not tell. So we have to use this concept here. And what do we do here? So one side xi plus it is given alpha ij double j. So we have to express in terms of the integral part plus the fractional part, and similarly right hand side integral part for the fractional part. So one side you keep all these integral part and other side all the fractional part. As a result, so we have here, because the finally ultimately we have the xi as integer, presently is not integer. So for all xi double j, the left hand side is an integer, hence the right hand side is also an integer. But fi minus summation over j varies from 1 to n, fij double j less than or equal to fi less than or equal to 1 is an integer. Okay. So ultimately we are finding fi minus this j varies from 1 to n, fij double j equal less than or equal to 0. Integer and less than 1. Integer less than 1 means 0 is possible. Okay. Okay. Less than 1, minus 1 also possible. Okay, so we are considering 0. Okay, -2 is also possible. So this, if you simplify, we are getting this type of constraint. Okay, this, and this generally appears in the dual simplex method. So we are using also the dual simplex method after finding the cutting plane. So, and this you can write in this fashion: summation over minus summation over j varies from 1 to n, fi j wj less than equal to minus fi. Fi is purely a fractional part. So we add a slug variable si, and we keep in this manner. Right hand side is negative. So as a result, it looks like the problem is infeasible, not infeasible. So here, this is the condition for the dual simplex method. Okay. So this problem can be solved using dual simplex method. This procedure is repeated till we find an integer solution. Okay. So if you have any doubt anywhere, now this is the time to explain. If you cannot understand that, then you cannot formulate. Okay. You will face problem. Now tell me, where is the problem? Okay, now let us go to the example. Okay, you see this example? See, this type of example, if I'm asking in the classroom, if somebody is solving without cutting plane, he can just enumerate and he can find solution. Can you guess the solution? 5x1 plus 4x2 and x1 plus x2 less than or equal to 3 and this. And we are looking for the maximum value. What is the maximum value? And what are the value of x1 and x2? Guess? Anybody? Anybody can solve?
Yes,
see,
sir.
Yes?
Yes, sir. Answer is 13, sir.
13. What
Yes,
is x1?
sir.
What is x2?
Sir, according to me, 5x1 plus 4x2, we can break it as x1 plus 4 times of x1 plus x2. So 4 times of x1 plus x2 would
No,
be
no,
less
that
than
is
equal
okay.
to
That is
12.
okay. But you tell me the answer. So I will check. What is the answer? What is x1 and what is x2? 13 you say? 5 into
1, 2. X1 and X2.
x1 is how much?
1.
1. x2?
Someone removed me from the meeting. X1 equal to 1 and x2 equal to 2.
2. 1 and 2. 8 plus 5. Okay. 1 and 2 is fulfilled. 1 and 2. 4 plus 2. Okay. Let me just, I will just, without the answer, complete answer, I want to know what was the answer you have guessed. Okay, 13, right? X1 equal to 1, x2 equal to 2. See, you are so intelligent. So why you need to solve? Without solving, you have got the answer. Okay.
Sir,
now
this was very small, sir. That's why we were able to solve.
Everything, we only start our life with small thing. Okay. So, you know, your birthday celebration is not a big party, a small party. Only few children will be there. And at your marriage party, thousands of people. So we start the life with the small thing, not big thing. Okay, right? And it is small problem. You can explain in the classroom, in the blackboard, in the white. Okay, like that. So here, you know the answer. So we have to reach the answer. So now you can verify. So let us see we are moving in the proper step or not. Okay, this is the problem. Initial simplex table. This is the initial simplex table you check. And I am using condensed form of the simplex table, not extended. Basic variable, non-basic variables. See the x3, x4, pi x3, x4, the slug variables generally, if you are writing s1, s2 is fine, but generally slug variables, you know, so the name x1 plus x2 plus x3 equal to 3. 4x1 plus x2 plus x4 equal to 8. The x3 and x4 are the slug variables. Okay. Hence, onward you can write, say, henceforward you can write. So this S1, S2, if you write, fine, but you try to avoid that, make everything X. Okay, right? All right. Any confusion here? If you say yes, we'll move. Now, after this table, we have the next table. Okay. I will not comment here. If any mistake, you can point out. So one of them, what is happening here? So -5, -5, -4. So most negative is the x1 is the entering variable. So which one is the departing variables? Okay. Now how will find the ratio? 3/1, 3, 8/4, 2. So what is happening? So minimum ratio is 2. So 2 is coming with respect to x4. x1 is the entering variable and x4 is the departing variable. Okay. So x4 is becoming the non-basic variable and x1 is becoming the basic variables and other thing remain unchanged. Okay. So you can see here. Okay. This. See, presently 0 was the maximum value. Now we have improved to 10. Okay. Next you see here. With respect to this, most negative, this is the negative. Okay. Now, x2 is the entering variable. If x2 is the entering variable, which one is the departing variable? 1 divided by 3/4. How much? 4/3. Say 2 divided by 1/4. 8. Say 4/3 is the minimum ratio. So x2 is entering and x3 is departing. x2 is entering and departing. Okay. So this, what is the value we are finding? So finally, this is the optimal solution. Optimal solution for non-integer. Say what is my beta 1? Who can say? What is my beta 1? x1, x2 in this order. What is my beta 1?
5/3.
5/3. Beta 1 is 5/3. What is my beta 2?
4/3.
4/3. The 4/3 we can write 1 plus 1/3. 5/3, 1 plus 2/3. Which is largest fractional part? Which is
Beta 1.
largest fractional part?
Beta 1.
x1. Means the x1 is non-integer with respect to beta 1. Beta 1 has the largest fractional part. So with respect to this, we are writing in this form. You can see here from this. So x1 plus 1/3 x4 minus 1/3 x3 equal to 5/3. Okay, this you got it. So and with respect to this, so here few steps are jumped. Finally, so the integral part and the fractional part considering we are finding like this. So with respect to 1/3 x4, the fractional part is 1/3 x4 and minus 1/3 x4 you can see here. So this, what is the fractional part? What is the integral part of minus 1/3? That is okay. So what is the integral part of minus 1/3?
-1.
-1. So whenever is minus, the complement will come. 2/3 x3 and right hand side greater than or equal to 5/3. So integral part is 1. So 2/3. So this is the constant. This is a cutting plane. Okay. So now this and this we will simplify. Now with this is a equation and second one is inequation. Okay. Now you add it or subtract it. If you subtract, what will happen? If you subtract, what will happen to this? So x1 plus 1/3 x4 minus 1/3 x3 equal to 5/3. You subtract, what will happen? If you are adding, what will happen, and subtract, what will happen? Okay, I'm subtracting. If I'm subtracting, so sir, there is a class. I'm taking a class, sir, after 1 hour. Okay, thank you. You subtract. If you subtract, you can see here. From the first one is equation, this is inequation. If you subtract, you can see here. So this minus this gone. 1/3 x4, 1/3 x4 gone. So and this is minus, this is minus. So this will be minus x1 minus x3, that is greater than or equal to 1. Is it all right? That is the cutting plane. So if somebody is asking what is the cutting plane we are finding, so this is equivalent to, if you express these two, first one is equation, this is inequation. If you combine these two, let us say I am combining in this manner, I am subtracting. So after subtracting, I am finding x1 minus x3, x1 minus x3 greater than or equal to 1. Do you believe it? Do you accept it?
So less than equal to 1.
So you are subtracting, no?
Then sign of inequality will reverse.
Acha. No. This minus this. Okay. Okay, less than or equal to 1, right? That is equal to this. Okay. Less than or equal to 1, right? x1 minus x3 less than or equal to 1. Okay, right? But we don't bother about that. We bother only this. Okay. We bother about this. And how to add to the earlier problem. How to add? So we'll add in this manner. Minus 2/3 x3 minus 1/3 x4 less than or equal to minus 2/3. Okay. Then you add a slug variables. Slug variable x1, x2, x3, x4 are there. What is the slug variable we need? Let us say s1, or I can say x5. One more. Okay. So this we are writing in this manner. This the slug variables with respect to this plus s1 is equal to minus 2/3. Okay. So why I am writing in terms of s1? Because a slug variables, so that you can recognize, yes, it is a slug variable. So in first cutting plane, you are introducing a slug variable s1. So minus 2/3 x3 minus 1/3 x4 plus s1 equal to minus 2/3. So what the problem we have got earlier? So there itself we have to add, make a space for this constant. Okay. But if you make a space for this constant, what changes you'll find? And you know, S1 was not there in the auxiliary function, so coefficient is 0. S1 is a slug variables. And what is the value of S1? Minus 2/3. So when negative is coming, so we will apply dual simplex. And what about the Zj minus Cj? This is positive, 1/3. This is 11/3. This is positive. Auxiliary function value is also 41/3. This is not changing. Whatever the earlier value, same value is there. And what we have done, we have added another row, another constant with respect to that constant, that is a row. So it is there in the simplex table. So we need not put more work, only additional constant is there. Now, so is it optimal? If you are adding and if you are applying the dual simplex, is it optimal? What is your answer? No, because all these right hand side values b1, b2, b3, etc. has to be non-negative, but there is a negative value. So with respect to the negative value, what will happen? So we'll have some. So the S1 is the departing variable. And once we are saying this is the departing variable, what is the entering variables? Either x4 or x3. So how to find? So you find in this manner. 1/3 minus 1/3, its absolute value. How much it is? 1/3 minus divided by minus 1/3 and its absolute value. How much it is? 1. Then 11/3 divided by minus 2/3, its absolute value. How much it is? 11/2. What is the minimum? Minimum occurs with respect to this one. Okay. So S1 is the departing variable. X4 is the entering variable. Okay. This you can see. X4 is the entering variable and S1 the departing variable. And you complete using the That's simplex rule. So we have got the answer here. X2 equal to 2, X1 equal to 1, X4 equal to 2. Okay. And S1 0, X3 0, and this is the optimal solution. Okay. And we can write the solution is like this: X1 star is 1, X2 star equal to 2, Z star equal to 30. Now I like to tell you everybody. So is it clear, or I will repeat? See, if it is not clear, you will not be able to solve any problem. There will be a lot of confusion. Okay. So let us come from the very beginning. You check yourself. This is from this is the table. Okay. Do you accept it? See, this type of problem I have asked in the exam also. This is the table. What is the value? What is the sum of the two basic variables? What is your answer? How much? Anybody? 11. What is the product of the two basic variables? What is your answer? Yes?
24.
Like that. So what is there? See, because the standard software will tell you X3, X4, but they will not tell you the product. Please remember. Okay. So then next table. Okay. This is actually what? In the initial simplex table. Okay. In this, that is the first table. And that is the, you can say this table number 1, table number 2, next table. What is the value of the basic variables? Now tell me. What is the value of the basic variable?
1 and 2.
1 and 2. And how much improvement we have in the objective function? Earlier it was 0, now it is 10. How many units we have improved?
10.
10 units. Okay. We will see that. So it is improving. Sometimes some problem there is no improvement. Now it is 10, in next iteration also 10. Then it is a case of degeneracy. Okay. So it is not degeneracy because it is improving. Okay. This. Next. Okay. This is the optimal solution. Okay. What is the value of the basic variable in the optimal? Sum of the basic variable in the optimal table. This is optimal for non-integer, not for integer. Non-integer. What is the basic variables here? X1, X3, X1, X2, and sum of the basic variables. How much? 4 by 3 plus 5 by 3. How much? 9 by 3, 3. And product? If I am saying product, 20 by 9. 20 by 9. Okay, this. So here, if you are asking, is there any alternate optimal solution for this problem? What is your answer? Alternate optimal solution for this problem? No, because the Zj minus Z1 minus C1, no, that is positive, but none of them are 0. If there are some of them 0, at least one of them 0, then there may be alternate optimal solution. Okay, cutting plane you have got, and we are finding this is the last table. Okay, so this is not a table because this is only a formulation, and last table value here. Okay, this. Say what are the sum of the basic variables in the last simplex table? How much? Last simplex table. This is the last simplex table. Sum of the basic variables. How much? 2 plus 2 plus 1. How much? 5. And product?
4.
Okay. So maximum of x1, x2, x3, x1, x2, x4. What is the maximum?
2.
Maximum is 2. What is the minimum? See, these are the questions we can frame. What else you can frame? Okay. So you have to establish the table and you take the conclusion. Okay. So every tables you have. Okay. Now, if I'm saying here, is there any alternate optimal solution?
No, sir.
No. That's all. So I will stop here. So tomorrow also, maybe I have told 6:30 to 8 o'clock, no? I have sent mail, no? Again, I will
Sir,
send.
I have not received your mail.
Yes, sir. We have not
received the
received many
question
mails
answer.
of yours, sir.
See, your ERP is creating problem. It is moving half an hour, and finally where it is going, I don't know. So what I'm doing? So I got your email ID. Okay. So from email ID, I'm copying in some site and sending. Okay. That is the simplest way. You do one thing. You have friend and you are doing teamwork. So if one is getting, you circulate. Okay. If you will not circulate, then what I'm saying, you are suppressing the fact. Okay.
Sir, many of our friends are also not getting, sir.
Okay. Now you be okay. I'm see again. I will send this tonight all the files whatever I have sent. Okay. So if you are getting, all right. If you are not getting, you ask your friend. At least who are getting, let us know. Okay. Tomorrow I will ask whether you have got or not. Because don't send mail because you know hundreds of mails I cannot reply. Okay. Right. But you ask your friend. Anybody has got? Then you asking me to forward. Okay. Right. Few of them certainly will get. You circulate.
And sir, on which mail do we have to submit the code?
Okay,
Like
these are the files I am going to send to you. Okay, I will tell you. The integer programming, this file. Okay, this file I am going to send. Well, this is a very crucial file. Integer programming, this file. Okay, and this file also I am going to send the dual simplex method. Already dual simplex method earlier I have given. So okay, again I am dual simplex method also giving because that is also useful. These two, and what else? Then I am giving the quoting plane methods. Some problems I have solved, some problems, and some questions are there. Okay. See if any mistake you correct and tell me that there are some mistakes. Okay, all right. Okay, 5 problems are there. And what else? And this test paper. Answer I have not given. Answer I have not given. I will give you the answer later on. So you try to find out the answer. If I am giving answer, you will manipulate. Okay. You should find your answer yourself. Okay. Right? Which problem is difficult? Now tell me.
Sir, can you discuss E part of second question?
Which part?
E part.
If x1, x2, x3 are free variables, then minimum value of the objective function.
Yes, sir.
Yes, sir. It could be minus infinity, no, sir?
If x1 are free variables, then minimum value. Okay. See what is given here. They are greater than or equal to 0. Okay. Solve by following question. Okay. Optimal. This is okay. This. If they are free variables, x1, x2, x3 are free variables. So we are talking about what? Huh?
Minimum value of the objective function, sir.
Maximum, minimum. Okay, maximum, minimum. So we are talking about the maximum and minimum. So minimum value, how much it will come?
Sir, didn't get the point, sir. Minimum
Tell me. Okay, what you will do? How to solve here?
Sir, minimum value of the objective function means minimum value of z equal to 3x1 plus 4x2 plus x3 plus 50k and x1, x2,
No.
x3.
See, how do you solve the problem here? So this is maximum, this is minimum. Okay. Now you are not using simplex. Okay. So in the first problem, see this problem, x1, x2, x3, x4 are greater than or equal to 0. Okay, greater than or equal to 0. So when you apply the basic feasible solution, this restriction is not there. Not there. Okay, it is not there. So we have a basic feasible solution. Okay, so basic feasible solution, all the variables has to be non-negative. Okay, so same thing here. Say you add x4 here and x5 here. Okay, so there are how many equations, how many unknowns? There are 3 plus 2, 5 unknowns and 2 equations. Okay, so based on that you will find the basic feasible solution. Okay, so free in the sense x1, x2, we are looking for maximum, and Okay, maximum and minimum. Okay, see this problem, maximum and minimum, sometimes maximum minimums are same. Okay, this is a basic feasible solution. Basic feasible solution. So this criteria I'm dropping. This criteria I'm dropping. Last one equation dropping. If I'm dropping means it is free. Say you will find a basic feasible solution. Okay, how to find basic feasible solution? So minimum or maximum. So you need basic feasible solution. Basic feasible solution cannot be negative. Will be negative? Okay. So this is given here to confuse you. So free variables, nothing mentioned. It is free. Basic feasible solution. Once you got the basic feasible solution, you substitute. That's all. Maximum, minimums, whether it's same
Where
or
is it that you have to report basic feasible solution? Means if they are free variables, then how
which one?
basic? Sir, free variables means there is no restriction on their sign.
Okay, okay. See, this first problem, how do you have solved?
But sir,
First problem, how do you
was a
have solved?
sign constraint, non-negative, right? There x1,
No,
x2,
this
x3.
last line you leave. Last line you leave. Okay. So you have solution? You have solution, no?
Yes.
What solution you have? Extreme points, no? Extreme points. Extreme points. Basic feasible solution represent the extreme points. Minimum or maximum occurs at the extreme point only, nowhere else. Okay. But here in the last line you can see these free variables, the x1, x2 are free variables in the sense. So I am not putting any restriction. Means I have told you find the solution using the basic feasible solution method. Okay, not by the simplex method. Okay, simplex takes care the variables are non-negative here. So that is also non-negative, but that is suppressed. Okay, you are looking for what? You are looking for some extreme point where minimum value will occur. Okay, minimum value. Okay, less than equal to that.
But sir, this problem is not bounded if we try to solve.
Okay,
this problem.
see, if that is you are thinking, okay, wrong, okay. Okay, all right, I will add 2 marks to everybody, that is okay. But some people has got already full mark, so they will get 32.
Sir, do this question bonus, no sir, means everyone get full marks for this question.
Which one?
For 2E, sir.
You have not understood the question, okay, right? I am telling, if I am giving a problem to you, okay, so there is 2A, we can solve a system of linear equation by linear programming method, and we are solving linear programming by finding the solution of a system. Okay, 2A. Using linear programming, you can solve a system. Whenever there is a system, linear equation, we have solution. The solutions are free. X can be positive, negative, 0. Okay. How to solve? Now tell me how to solve a system of linear equation by linear programming. What is your answer? Tell me. X equal to B is given to you. You want to solve using linear programming. How will solve? Tell me. After learning so much, if you cannot solve them, there is some fault. X equal to B. And may be square, may not be square, no problem. How to solve? X equal to B, you want to solve using, for example, you have developed a code which will solve a linear programming problem. Using that code, you want to solve X equal to B. You are using your code to solve this. How to solve? You have to formulate the problem. How to formulate? See, there are n number of free variables. So n number of free variables, you will introduce for each variable 2 variables, the difference of 2 variables. Okay. So if x1, let us say x1 equal to x1 dash minus x1 double dash. Okay. Both x1 dash and x1 double dash are non-negative. So n variables becoming 2n variables. Okay. Now it is equation. It is equation. So for equation, so you have to add artificial variables. For each equation, you have to add artificial variables. Artificial variables are non-negative. Okay. So that artificial variable, some of the artificial variable you have to minimize. What you do in the two-phase simplex method. So minimize artificial variable number 1 plus artificial variable number 2 at so and so. Let us say m number of artificial variable. plus last one is artificial variable m. Okay, and if you can say all the artificial variables are 0, then you are finding a solution. If it is non-zero, then the problem is infeasible. Okay, after finding that, you will have this value of all these 2n variables and use it and find the value. That's all. You understood what I'm saying? So system can be solved using simplex method. So again, using system we are solving simplex method, vice versa. Okay. You are saying minimum value of the auxiliary function will be minus infinity. If x1, x2, x3 are free variables, see, free variables means I will drop. If I'm dropping, so how it will be infinity? Tell me, what way you got infinity?
Sir, minimization objective with less than equal to constraint. So it will be.
Forget about that. Forget about that. You are adding some slug with respect to this problem. You are adding some slug variables. Okay. After adding slug variables, say what you do? You find the basic feasible solution. Okay. So after finding the basic feasible solution, you will find maximum and minimum. Where is becoming maximum and where is becoming minimum? That you have to find out. Okay. See, after finding the basic feasible solution, one will give maximum, another give minimum. Okay. For example, I'm saying maximize x1 plus x2. Maximize x1 plus x2. So x1 plus x2 less than or equal to 10. Okay. Right? x1 plus x2 less than or equal to 10. Okay. And what is the maximum value? x1, x2 are non-negative, let us say. What is the maximum value? Tell me, what is the maximum value? It has several solutions. Maximum value is 10. I'm saying maximize x1 plus x2. And what is the minimum value? How much? Simply say x1 plus x2 equal to 10. And maximum minimum will be same. x1 plus x2, let us say equal to 10. I'm saying very simplicity. x1 plus x2 equal to 10. Okay, one equation only. So, and we want to maximize x1 plus x2 and minimize x1 plus x2. Okay, free variable or not free variable? What will happen to that? x1 plus x2 equal to 10. If you are saying x1 equal to minus 90, x2 will be how much? 100. My 90 minus 90 plus 100 equal to 10. Okay, so sum will be safe, constant, same thing, no? Here, if I am saying it is greater than or equal to 0, so you will start from 0. 0 to 10, 10 to 0, something like that. Okay. But here anything, but the sum equal to that. This in simplex code you have written here. How many you have developed written the simplex code? Simplex. Okay. Tell me how many? It is difficult. See, I am observing anything is given. Even my children also, if anything is given, first they will search in the net. Then they will search in their network, student network. Okay. Then you will ask in other IIT network. Okay. See, this is not the way. You should try yourself. See what way I am teaching so that they do not know. You have to explain them. See, if you are asking some valid question, I agree. Yes. Sometimes some questions are confusing. Okay. Everywhere it is confusing. Okay. I have made free variables. You have to understand what is free variable. Okay. Now this free variable make it say restricted variable. Where is it wrong? The x1, x2, x3 you make it restricted. So x1 will be difference of 2 and difference of 2 and proceed. And your life will be still more miserable. This free variable you can make restricted. Okay. And proceed. What is happening to that problem? Okay. So this 2 marks don't bother. Even I'm telling for grading, you know, to round off your grade. So I can maximize, you know, I can give 5 marks, not more than 5. Maximum I can give 5 marks. Okay. But I cannot give 20 marks. Please remember. Because it is grade. So if you are getting 85, I will make it 90. Okay. If you are getting 55, I will make 60. Okay. So I am not that way measure. So, but problem is the 55 I cannot make 50. I cannot add 15. Please remember. It is grade, no. the students should not lose. Okay, thank you. So we'll stop here. So tomorrow we'll meet. What time? 6:30 to 8 o'clock. Please inform all. I'm sending mail to everybody. Okay. So through the ERP, and if you are getting, I have to send 3 mails. Okay, for 3 files, 3 mails. Okay.
So
Sir,
for
my attendance
attendance, I
remaining.
wanted to say, sir, 20 CS 3001, sir, attendance, sir.
I will mark all students at present. Okay, tomorrow I will call. Okay, because many they could not realize that they will class. Okay, tomorrow we'll start where I have stopped. Again, I will start there. Okay, they should not lose also, right? But I am requesting everybody you solve yourself. See, forget about. You may get wrong answer, but you try yourself and you reproduce the answer. Okay, don't copy from anybody. You try yourself so that you will understand. Okay. This x, the 1e, x equal to 6131. How it is possible? If you solve the problem, then you'll realize 6131. How it is possible? See, simplex method say only out of 4, 2 will be the basic variable, 2 are non-basic variables. Okay. How 4 are the becoming positive? How?
Sir, linear combination of
linear combination. See,
solution.
you have understood. Okay, that's how. Okay. And there is a problem, there is a question from the duality we have answered. Check whether a given solution is optimal or not. Check using the duality. So if you want to check, see for this problem, if you leave that, so use the duality theory. Okay. So as you say that infinity, duality theory apply. So if I'm making this free, maximize this type is free. So what will happen to that? Free variable means it will equal to free variable means it will equal to come. Duality theory. And what the duality theory is giving? It is giving infinity. There are 4 models I have given in the duality theory. The 4 model, one of the models say constants are less than equal type and the variables are free. Free means dual variables will be, there are 3 variables. So there are 3 equations will be equivalent type. Okay. And the problem will be minimization type. Try it. What will happen to that? How many infinity is coming? Let us know. You apply the duality theory here. Okay. Okay. I will check again. So if any mistake. Anything you want to say? Okay. Thank you. So